All right, here we go. This is called Newton's Cradle. We'll use it to reinforce conservation of momentum. We can talk about energy and forces and everything, but the focus here is going to be momentum. So I want you to make a prediction right now, and that is if I take one ball, raise it up, right now that's where the conservation of energy term would come in. How many balls are going to bounce on the other side? And so if you, right, since I'm holding one, if you predicted one, you're probably going to be right. And this. Now this frame, right, metal's got on a base on a table there. Okay, so as you're getting sleepy already, let's try, stop this. Now how about two? And you're like, well, if there was one before and now there's two, so this is still fairly easy. I'm going to hold the base. And you, in fact, do see that two bounce off because the impulse transferred sends it through and bounces two. So let's get tricky now with it. And now I'm going to do three. Right? There's 5 balls and 2 left. So now how many are going to move? And so now it gets a little bit trickier. Usually you guys are there and there's a debate on how many balls. So you need to make your prediction. Is it going to be 2? Is it going to be 3? Is it going to be 1? So ready, set, and it's 3. Now why is that? Well, that is due to conservation of momentum. And next, all right, how about 4? And you can see that again, 4 on both sides. Okay, now how about 5? All right, so now before we wrap up, we've done all of them in one line. Now what if I do 2 and 1? Right, what's going to happen? And you see them switch. Okay. What if I do 3 and 2? You see them switch. Basically, they seem to just be transferring the one bearing in the middle. And bonus. And now you see them transfer out on those. So every combination or permutation of this that you could do would get exactly the same result. Backing up or reinforcing, doesn't need backing up, but reinforcing for you that total momentum in a closed system is conserved. Now you can see up here, the wires are thin, and so the goal is that very little energy or forces are moved away from the axis of the bearings, keeping everything in a closed system as best we can. All right, over now.